When updating a mobile home's electrical service to 200 amps, proper grounding is crucial for safety and code compliance. Two primary methods exist for grounding the service, both adhering to the National Electrical Code, or NEC. Firstly, you can utilize the bare aluminum wire from the existing service entrance, or C cable, as the grounding conductor. Secondly, you have the option of using a fourth insulated conductor as the grounding conductor. Let's explore both methods in detail. Firstly, using the existing SE cable's bare aluminum wire as the grounding conductor involves several steps. Before commencing any electrical work, ensure power is completely disconnected. This involves turning off the main breaker in both the outside and inside panels. Next, carefully remove the SE cable from the outside panel. Loosen the cable clamps securing it and gently extract the cable. Identify the bare aluminum wire within the SE cable assembly. It will be the only uninsulated wire present. To clearly designate its function, mark the bare wire by wrapping a piece of electrical tape around it. This signifies its role as the grounding conductor. Now run a fourth insulated wire from the outside panel to the inside panel. This conductor will serve as the neutral. Connect one end of the fourth wire to the neutral bus bar in both the outside and inside panels, ensuring a secure connection. Then connect the bare aluminum wire, previously identified and marked, to the grounding bus bar in both the outside and inside panels. It's paramount to ensure all connections are tightened and secured to prevent loose connections, which can lead to electrical hazards. Finally, reinstall the SE cable back into the outside panel and tighten the cable clamps to secure it in place. With all connections made and secured, turn the power back on by switching on the main breakers in both the outside and inside panels. Alternatively, the second method involves utilizing the fourth conductor as the grounding conductor. Again, safety is paramount, so begin by disconnecting power to both the outside and inside panels. Remove the SE cable from the outside panel by loosening the cable clamps and extracting the cable. The next step involves separating the fourth conductor from the SE cable. Carefully cut the fourth conductor and isolate it from the other three wires within the SE cable. Since this conductor will now serve as the ground, it must be insulated. Wrap the fourth conductor thoroughly with electrical tape to ensure it is properly insulated. Connect one end of the insulated fourth conductor to the grounding bus bar in both the outside and inside panels, creating a solid grounding path. Reinstall the SE cable back into the outside panel and tighten the cable clamps. Conclude the process by turning the power back on, switching on the main breakers in both panels. It is imperative to consider several important notes regardless of the grounding method chosen. Fourth conductor must be properly sized in accordance with the NEC to handle the potential fault current. Grounding and neutral conductors must be kept separate except where explicitly permitted by the NEC, typically at the service entrance. All connections must be made in accordance with the NEC and local building codes to ensure safety and compliance. Remember that electrical codes are in place to prevent fire and electrocution hazards, so always adhere to them strictly. The selection of the appropriate wire size for the neutral and grounding conductors is a critical aspect of electrical safety. The NEC provides specific tables and guidelines for determining the correct wire size based on the size of the service entrance conductors and the anticipated load. For a 200 amp service, the neutral conductor is typically sized based on the calculated neutral load, which may be smaller than the service entrance conductors. However, the NEC specifies minimum sizes for neutral conductors, and it is essential to adhere to these minimums. The grounding conductor, on the other hand, is sized based on the size of the service entrance conductors, as it must be capable of safely carrying fault current back to the source. When using the bare aluminum wire from the SE cable as the grounding conductor, it is important to ensure that the wire is in good condition and free from any damage or corrosion. Aluminum wire can corrode over time, especially in the presence of moisture or dissimilar metals. If the bare aluminum wire shows signs of corrosion or damage, it should be replaced with a new grounding conductor. Similarly, when using a fourth insulated conductor as the grounding conductor, it is important to ensure that the insulation is intact and free from any damage. Damaged insulation can create a shock hazard and compromise the safety of the grounding system. Proper bonding is also essential for a safe and effective grounding system. Bonding refers to the connection of all metal parts of the electrical system, such as metal enclosures, raceways, and equipment grounding conductors, to the grounding electrode system. This ensures that all metal parts are at the same potential, which minimizes the risk of electric shock. The NEC specifies the requirements for bonding, including the types of bonding connectors and methods that are permitted. It is important to follow these requirements carefully to ensure that the bonding system is properly installed. In addition to the grounding conductor, a grounding electrode system is also required. The grounding electrode system provides a connection to the earth, which helps to stabilize the voltage of the electrical system and provide a path for fault current to flow back to the source. The NEC specifies the types of grounding electrodes that are permitted, such as ground rods, metal water pipes, and concrete encased electrodes. The grounding electrode system must be properly installed and maintained to ensure that it is effective. When working with electrical systems, it is always important to follow safe work practices. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses. It also includes using insulated tools and testing equipment to avoid electric shock. Before working on any electrical circuit, it is essential to verify that the power is off using a voltage tester. Never assume that a circuit is de-energized simply because the breaker is turned off. If you are not comfortable working with electrical systems, it is always best to hire a qualified electrician. A qualified electrician has the training and experience to safely and properly install and maintain electrical systems. They can also ensure that the electrical system is in compliance with the NEC and local building codes. Attempting to perform electrical work without the proper training and experience can be dangerous and can result in serious injury or death. The NEC is updated every 3 years, so it is important to stay up to date in the latest requirements. Changes to the NEC can affect the way that electrical systems are installed and maintained. It is also important to be aware of any local amendments to the NEC that may be in effect in your area. Local amendments can add or modify the requirements of the NEC to address specific local conditions. In addition to the NEC, there may be other codes and standards that apply to electrical installations in mobile homes. These codes and standards may address specific issues such as fire safety, energy efficiency, and accessibility. It is important to be aware of these codes and standards and to ensure that the electrical installation is in compliance with them. When performing electrical work in a mobile home, it is important to be aware of the unique challenges that mobile homes present. Mobile homes are often smaller and more compact than conventional homes, which can make it more difficult to access and work on electrical systems. Mobile homes may also have different wiring methods and materials than conventional homes. It is important to be familiar with these differences and to take them into account when performing electrical work. Proper grounding is essential for the safety and proper functioning of any electrical system. By following the steps outlined above and adhering to the NEC and local building codes, you can ensure that the electrical service in your mobile home is properly grounded. Remember to prioritize safety and consult with a qualified electrician if you have any questions or concerns. Always double-check your work and test the system after making any changes. Grounding is a critical safety component, and it's worth the time and effort to get it right. Also, remember to consider the environmental factors and potential for corrosion, especially in coastal or humid areas. Regular inspections can help identify and address any potential issues before they become major problems.